All right, so we've got the x-axis, x equals -2, and then y equals -2x, which is this line. And we're going to revolve that around x equals -5. So here is my ghost shape on the other side. And it's going to be like a really wide funnel, basically. So there is a hole in the middle. It's going to be a Washer's problem. This is going to be pi r squared minus r squared. And then you have to decide if it's dx or dy. It's like we just took the y-axis and moved it over a little bit. So it is going to be a dy problem. And so as soon as you realize it's dy, you have to go back and rearrange this equation. So we're going to divide over the -2. So you can write it as y over -2 or -1/2 y. But you have to get x by itself. You have to rearrange the equation. And we're going to use our y values for our boundaries. So it's going to go from 0 to 4. Now let me color code this here. So the outer radius is right graph minus left graph. So the right graph is this line. So that's the -1/2 y minus, and then the left graph is -5. So it's minus -5. That'll be +5. And then the inside radius, again, right graph minus left graph. Well, the right graph is -2. And the left graph is -5. So it would be -2 minus -5. Those are going to cancel and be +5. And so that just ends up being 3. The other thing you can do is you can just look at this and go, oh, from there to there is 3 units. So that inner radius is 3. Now this one you did have to work out by hand. So we're going to have to multiply out this first part. If you want to write that twice off to the side, -1/2 y plus 5, -1/2 y plus 5. We're going to distribute all of that to each other. So that will give us +1/4 y squared. The outsides give you -5/2 y. The insides give you -5/2 y. So that's going to be -5 y. And then 5 times 5 will be 25. And then -3 squared is 9. And I'm just going to erase and combine those together. 25 minus 9 will give us 16. So we've distributed everything, combined the like terms. Now we're going to do the antiderivative. So for this first part, it would be 1/3 y cubed, but there's already a 1/4 there. So 1/3 times a 4th will be a 12th. So 1/12 y cubed minus 5/2 y squared plus 16y. From 0 to 4. And I told you, you didn't need to simplify any of these down. So all you really have to do is plug in the 4. And some of you obviously simplified it further, and that's fine, but you don't need to. And if you made a mistake, then I had to mark it wrong. Although that didn't really happen to anybody because you guys are pretty good about that. But all you need to do is plug in the 4. All right, and then someone had said 7. So let's look at number 7. This is one where you have cross sections coming up out of the paper at you. So you have to turn on your imagination. All right, the base is bounded by the graphs of y equals square root of x plus 1 and y equals x over 3. That's 1/3 x plus 1. So let me start by going ahead and graphing those. So y equals square root of x plus 1. So that's going to start at 0, 1. And then let me just plug in some numbers that are perfect squares. If you plug in 1, you're going to get 2. If you plug in 4, you're going to get 3. And if you plug in 9, you're going to get 4. Right, so something like that. And then 1/3 x plus 1. So it's going to also start at 0, 1. Slope is a 1/3. So up 1 over 3. So you get this teeny little slice in here. And it says that our shapes are rectangles. The height is 4 times the base. And they are perpendicular to the y-axis. So our slices are going this way. And so as soon as we realize it's a dy problem, we have to go back and rearrange these equations. So I'm going to subtract 1. And then to get rid of the square root, we're going to square. And then here again, we're going to subtract 1. And then to get rid of the 1/3, we're going to multiply by 3. You would have to distribute it to both terms. So 3y minus 3. So these are the two equations that we're using. Our shape is a rectangle, and the base of it matches up with right graph minus left graph. So the right graph is the line, that's this one, the 3y minus 3. So that's the right graph, minus the left graph is the curve. So that's this one, the y minus 1 squared. And then the height is going to be 4 times that. I'm not going to write it out again, but it would be 4 times all of that. So we're ready to set up the integral. We want y values for the boundaries. So from here to here, it's going to be from 2, where is that? From 2 to, sorry, I don't have a grid. Oh, not 2, 1. Is that from 1 to 4? Sorry, I don't have a grid, so this isn't very good. Yeah, 1 to 4. There we go. So using your y-axis, so 1 to 4. And inside of there, you're going to put the area of your shape. So it's base times height. Again, the height is 4 times this. So you're going to have 4 times all of that squared. Because it is that times itself, it's just the height is 4 times that. So this one you're allowed to type in the calculator. I know it says y, but we're still going to type x because you have an x key, so that's easier. We have integral from 1 to 4, and then 4 times, let's see, 3x minus 3 minus parenthesis x minus 1 squared, close parenthesis, the whole thing is squared, and then dx. And it comes out to 32.4. And because that decimal ends, you don't need to put 3 decimals, it just stops. But a lot of you did put 0, 0 at the end there. And I'm glad you know that you need 3 decimal points usually. It's just since this one was literally just 32.4, like period, end of story, you can just write it like that. And I will do one more if you guys would like to pick a third one. Is there another one that you guys want to look at? Okay, I'm not hearing anything else there, so I'm going to go ahead and stop the recording.